Right, this is your 6-6 notes over systems of inequality. So it says the solution of a system of inequalities is a set of all ordered pairs that satisfy both inequalities. If you graph the inequalities in the same coordinate plane, this is your important part right here. Your solution is the region where the graphs overlap. Okay, so a reminder about a couple of things. If you have a less than or a greater than inequality, you're going to have a dotted line. If it's less than or equal to, or if it's greater than or equal to, you're going to have a solid line. So if you don't have a line on the inequality, a solid line on the inequality, you're not going to have a solid line on your graph. And then if you have less than or equal to, you're going to shade down. If you have a greater than or equal to, you're going to shade up. All right, so I'm going to go through these 6 examples. Okay, so the first one, we have y is greater than -1. So a couple things that you need to write down that you know about this is, one, you're going to have a dotted line. Okay, and 2 is that since it's greater than, you're going to shade up. So what does that look like? Well, you are going through the y-axis at -1. So here's -1 on the y-axis. It's a dotted line. And since it's greater than, you're shading up. So all of this in here will be shaded. Okay, and the second one, x is less than 0. Again, this is a dotted line. And because it is less than, you're going to shade down. Just do my arrow. So you're on the x-axis at 0, right here. It's a dotted line. So I'm going to go up and down. Okay, so we say shade down, but really you can't shade down in this one. So it says x is less than 0. So if you look at the x-axis, your numbers that are going to be less than 0 are going to be negative. So -1, -2, and so on. So really it's not so much shade down for this one, but it's going to be shade to the left because those are the numbers that are less than 0. So all of this over here is going to be shaded. All right, so like the graph said, or sorry, not the graph, the words at the top, like they said, where these two overlap, which would be right here, okay, in this area, this is where your answers are. So that area is where your solution is. So I'm just going to draw a little arrow and write solution. Okay, your solution is not on the line though, because those are dotted lines, so they can't be equal to those numbers. If it was a solid line, your answers could be on that line. All right, number 2, y is greater than -2x plus 2. So first is going to be a dotted line, and you are going to shade up because it is greater than. Okay, I know my slope is -2, and I know my y-intercept is 0, 2, because this is already in slope-intercept form. So I'm going to go ahead and plot the point 0, 2, so 0, 1, 2. And since my slope is -2, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, and then I'm going to do the opposite, so up 2 over 1, and I can't go any further. So it's a dotted line. So do little dashes through my points. And I'm shading up because it says greater than, so all of this is going to be shaded in. Okay, and then my second equation that I have is y is less than or equal to x plus 1. So I know this is going to be solid, and since it's less than, I know it's going to shade down. Okay, so my slope is 1 because that's the coefficient, which is the number in front of x. And my y-intercept is 0, 1 because that's the last number that I'm adding or subtracting. So I'm starting at 1. And since my slope is 1, I just go up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, and I do the opposite. So down 1 over 1, down 1 over 1, until I can't go any further. It's a solid line, so I'm going to connect my dots. Okay, and I am shading down because it's less than, so all of this in here would be shaded. Okay, and again, where these two overlap, so they overlap right in this area. Okay, all of this will be your solutions. So I'm going to write over here. Solution. So any point in that graph would be a solution. Okay, third one. So the first one we have y is less than x plus 1. So this is a dotted line. And you're going to shade down. So your slope is 1, and your y-intercept is also 1. So I'm at 1 from my y-intercept, and then my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 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 1 over 1. It's a dotted line, so I'm going to do little dashes through here. And I had to shade down, so all of this is shaded. And again, you shade down because your inequality says it's less than. Okay, and the second equation, 3x plus 4y is greater than or equal to 12. First thing I'm going to do is I'm going to put this into slope-intercept form. So hopefully you remember this from the first section. You have to do the exciting move. So that means I got to move this x on over. So I have 4y is greater than or equal to, that positive 3x becomes negative, plus 12. And I also have to do the great divide. So I'm going to divide everything in here by 4. It's not a negative, so I don't have to flip my inequality. So what I'm left with is y is greater than or equal to negative 3 over 4x, and 12 divided by 4 is 3. So now, from this, I know that I'm going to have a solid line, and I know that I'm going to shade up because it is greater than. I also know that my slope is negative 3 over 4, and I know I'm starting at the y-intercept, which is 0, 3. Okay, so I'm going to plot my point 0, 3. So 0, 1, 2, 3. And my slope was negative 3 over 4. So I'm going to go down 3. 1, 2, 3, and over 4. 1, 2, 3, 4. And that's all that I can do because if I go the opposite direction, my point is off the graph. This is a solid line. So I'm going to go ahead and connect those two dots the best that I can. And I also am going to shade up because it's greater than. So all of this in here is going to be shaded. And I know that my answer is going to be right in here. So that is where my solutions are. So what that means again is that any point that you pick in that area is a solution to this inequality. So for example, if I was to pick, let's see, 1, 2, 3, 4, 4, 1. Okay, so that's this point right in here. If I were to pick 4, 1, okay, here's my x and here's my y. If I were to plug those into my equations right here, then I know that those statements, once I plug that in, would be correct. All right, so we're halfway done. We got 3 more to do. So for number 4, I have 2x plus y is greater than or equal to 1. So first thing I'm going to do is put this in a slope-intercept form. Before I even talk about dotted and solid and all that stuff, I'm going to just put it in a slope-intercept form. So I have y is greater than or equal to, that positive 2x becomes a negative, plus 1. And I don't have to do a great divide on here because you have y by itself. So what I know from this is that I do have a solid line, and I know that I'm going to have to shade up because it is greater than. I also know that my slope is negative 2, and I know that my y-intercept is at 1. So I'm starting at 1, which is right there on your y-axis, and since it's negative, I have to go down. So down 2 over 1, down 2 over 1, down 2 over 1, and I'm going to do the opposite. So up 2 over 1, up 2 over 1. Okay, it is a solid line, so I'm going to go ahead and connect my dots. And I have to shade up, so all of this will be shaded. Okay, and my second graph, what I'm going to do, f x minus y is greater than or equal to 2. Make sure. Yes. Okay. Negative 2. Negative 2. Okay, so for this one, again, I'm going to do the exciting move. So be careful, because what I have left is a negative y. So we have a negative y is greater than or equal to positive x becomes a negative, and you have a minus 2. And then I'm also going to do the great divide, because I need that to say y. That says negative y. So to fix that, I'm going to divide everything by a negative 1. So what I end up with, one more thing. I'm dividing by this negative. Okay, so what that means is that you draw your face, and what that means is that I have to flip this inequality. Okay, so when you divide by a negative, all that it does is change the sign. So the negative x and the negative 2 become positive. So positive x and positive 2. And I'm going to rewrite this just to make it look nice. So y is less than or equal to x plus 2. So I know I'm going to have a solid line, and I know I'm going to shade down because it's less than. So that means that my slope is 1 and my y-intercept is going to be at 0, 2. So I'm starting at 0, 2. So 0, 1, 2. And my slope, make sure I said it was 1. Yes, slope is 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to do the opposite. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay, and this is a solid line, so I'm going to go ahead and connect my dots. And I need to shade down because it's less than. So all of this is going to be shaded. Okay, and again, my answers, so my solutions are going to be right in this shaded area. And it actually includes the points on the line because those are solid lines. And since they are solid, my answers are allowed to be on that line. Okay, 2 more. So this next one's really nice because these are already in slope-intercept form. So y is less than or equal to 2x plus 3. So I know that I'm going to have a solid line, and I know that I'm going to shade down. I know my slope is 2, and my y-intercept is 0, 3. So 0, 1, 2, 3. And I'm going to go up 2 over 1, which means I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. I'm going to go ahead and connect my points. And I'm going to go ahead and shade down because it's less than. Okay, and the second one that I have is y is greater than or equal to negative 1 plus 2x. Now they're trying to confuse you on this, but slope-intercept form, you just put the x in front and your constant in the back. So you just flip-flop them. Okay, so for this one you have a solid line. And again, you're going to shade up because it's greater than. So your slope is 2. And your y-intercept is 0, negative 1. So I'm at negative 1. And my slope is 2. So it's the same slope as the first one. So without even plotting this, I already know these lines are going to be parallel because parallel lines have the same slope. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to go down 2 over 1, down 2 over 1. And again, this line is going to be solid because I have an equal to on the inequality. And for this one, I'm shading up. So all of this will be shaded because you're shading up. But your answers are going to actually be right in like this little quadrilateral. Your answers are going to be right in here because that's where they overlap. So for this, that's where my solutions are. And again, your answers can be on your solid lines because they're solid. All right, last one. So we have 5x minus 2y is less than 6. So before I do anything, I'm going to go ahead and put this in slope-intercept form. So what that means that I have to do is my exciting move. So I will have a negative 2y is less than positive 5x becomes a negative. And I am going to have to do the great divide. So I'm dividing by a negative 2. Now here's the thing. When you divide by this negative 2, you have to put your face on here because you're dividing by a negative. So what that means, the reason why we do the face, is so that we know we have to flip my inequality. So negative 5 and negative 2 just gives me 5 over 2 because those negatives cancel out. And 6 divided by negative 2 is a negative 3. I'm going to rewrite this to make it nice and neat because you're not going to see circles on your test. And so now I know that I'm going to have a dotted line, and I know that I'm going to shade up because it's greater than. I also know from this that my slope is 5 over 2, and I know that my y-intercept is at negative 3. So I'm at 0, negative 3. So 0, negative 1, negative 2, negative 3. And my slope is 5 over 2. So I'm going to rise up 5. So 1, 2, 3, 4, 5 over 2. And I cannot go anymore because it's going to be off the graph. So I'm going to try to make this a dotted line, which is kind of hard when you only have 2 points. Just try your best though on that. And again, we are shading up. So all of this will be shaded. Okay, and then the last equation I have is y is greater than negative x plus 1. So y is greater than negative x plus 1. So I know this is going to be a dotted line. It's already in slope-intercept form, and I'm also going to shade up on this one because it is greater than. My slope here is a negative 1 because that's your coefficient in front of x, and my y-intercept is 0, 1 because that's the number that I'm adding at the end. So I'm starting at 1. And my slope was a negative 1, so I'm going to go down 1 over 1, 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 up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and again, it's a dotted line, so I'm going to do my little dashes, and it was greater than, so I had to shade up, so all this is going to be shaded, okay, and my answer is going to be right in here. But it's not going to be any of the points that are on the line because my lines are dotted. And again, if they're dotted, then you cannot have a solution on the line. It has to be solid in order for there to be a solution on the line. So the area that is highlighted in orange, though, all those points in there, those would be solutions to the system of inequalities. That's it. That's all that you have to do.